Okay, for those of you who were absent today, we just are comparing some of our data that we have because tomorrow is your limiting reactant and percent yield evaluation. I'll try to get those papers handed back, providing that there's time. Okay, and the reason for this activity is rather than just always talking about this, just like when you did your Bohr models from physical science. You do it on pencil and paper, it's just two-dimensional, okay? You might not get a whole lot of that. So then you take some M&Ms, some Skittles, anything like that. Now you see these atoms in 3 dimensions, and hopefully that adds a little bit of context to it. So the reason for this exercise then is hopefully we're learning and getting raw data that would align up to what we're learning in the textbooks. So, are there places to make mistakes? Yes, okay. And perhaps some of the simplest ones, yeah, it's that simple addition. The formula weight for sodium chromate is 161.97, so somewhere around 161. And then for silver nitrate, should be somewhere around 169.87, straight off the bottle. So 169 should be fine. Okay, so if we had some of this, we know that we took silver nitrate. Okay, and then we added sodium chromate. Oops, that's not right, is it? I think it's, isn't it 04? Yep. So then this should be A4. And then these ions, they don't change in charge. So this should be pretty easy to balance, correct? Because none of the charges are changing. So if it's a +1 on one side, it's a +1 on the other. And that balances out, that balances out. So if we had some sodium nitrate, remember that's water soluble, so that's your liquid portion. And then we've got some silver chromate. Okay, so here is your precipitate. Okay, so do we want to pick one group or just make up a random number? Sorry? Okay, so one of the things I think we had said, try to have this around, what was it, 5 grams? Yep. Okay, so if this is 5 grams, and we'll, how much for this? 15. Okay, well, we'll make it a palindrome. That's a palindrome. That's a number palindrome. Can anyone give a word palindrome? Yeah, race car, noon, mom, dad. You didn't say croquet, did you? No, taco cat. Oh, okay. That's the cat's meow. Yeah. Yum. Would you rather have tacos today? Or the... I know it's quesadilla, or was the quesadilla better? Quesadilla? Okay. Yeah, if you say that, you just sound like an idiot, so like that wouldn't be any different than whatever I talk about. Okay. So what you can do, again, you've got to decide, am I a mole-to-mole person doing battleship? Or am I a mass-to-mass person calculating limiting reactants, okay? But one of the things to maybe think about, and it's tough to go back and forth and back and forth and back and forth, I know, and sometimes maybe it's just easier to go mass to mass all the time, okay? It is perhaps a little bit shorter, but it's easier to make it's a little bit longer, but it's easier to make a mistake when you go mole to mole all the time. But what we're going to do is we're going to change it to grams of that anyway. And if you had calculated your limiting reactant, it should be silver nitrate, correct? Okay. So that's been up on the board. I just put that up there so I wouldn't forget. But we will illustrate that now. So with that, we're going to take 5 grams of silver nitrate, and we're going to convert that to grams of silver chromate. Okay, and I'm just going to use, I think, what did I say, 169 point something. That's good enough for us for what we're doing. That gives you a mole of silver nitrate. Okay, so what is our next step? Okay, so again, what we're doing is you're always trying to cancel out your factors. And even though this next step doesn't have anything to do with the math, if you understand that, then you're well on your way of doing well from here until probably sometime in March. So when we say, mathematically speaking, this next step really has no bearing, does it? And if you understand that, why is it? Because it's just 1 to 1. But what it is doing is it's allowing us to get from this side of the equation all the way over here to where we want to be. So how do we get rid of this mole of silver nitrate? Okay? Because if it was the case, if there's any coefficients, it's in this step is where you need those coefficients. But since there is none, we can just go ahead and move on to our final step. And then that would be grams of silver chromate, sorry. So that means this is roughly 107 chromium. That's what, 53? 52. Okay. And then 64. So 9, 13, 1, 6, 12. So around 223. Okay. So 223 grams of silver chloride. I did it again, silver chromate. Okay. So when you multiply those out, okay, here's my calculator out. We take 5 times 223 and then divide that by 169 and we get 6.60 when you round to the nearest hundredth. So 6.60 grams of silver chromate. I'll just go ahead and write that out this time. Okay. Can we deduce whether that's our limiting reactant yet? No. No, we cannot. It might be a pretty good indication, but chances are when we convert grams of this to silver chromate, it's probably going to be a larger amount. But let's just go ahead and illustrate that. 15.51 grams of sodium chromate. Okay. Then for every mole of, I'll go ahead and write that out so those of us tuning in a little later know we've got sodium chromate here, not silver chromate. So sodium chromate, and that value was 161. Yes, 161. Okay, this next step was allowing us to get to the other side of the equation. And then this number would still be the same, 223 grams of AgCrO4. Okay. So we take 15.51 times 223, and we divide that by 161. That gives us 21.48. Okay, this is a smaller number, so just as we had slightly predicted silver nitrate, this is our limiting reactant. We just showed that mathematically now. Okay, so once we've done that, okay, with our limiting reactant, this is our precipitate. But which one do we choose? Is it the bottom one or the top one? Why are you right?
That was the one from the limiting reactant.
Yes, you have to use your limiting reactant, which we said is this. Okay, I understand we're calculating grams of silver chromate in both cases, but this one is not our limiting reactant. This one is. Okay, so now you can do your percent yields, which would mean, and hopefully this gives us good data. Your percent yield would say we are supposed to get 6.60. So when you do this on pencil and paper, is that an actual yield or a theoretical? That is a theoretical yield. On pencil and paper, we're supposed to get 6.60. Okay? What you just measured for the second time. Okay? Did you get a number smaller than your theoretical yield?
Yes.
Okay. So sometimes that can be something that can throw your data off. You might have been thinking, oh my gosh, this math is not working out. But again, there's a lot of water tied in with that precipitate. Once that evaporated out, okay? So would I be led to believe that some people got 5, 4, maybe even 3 grams? 3, 3.1. You got 6? 6.2. You're the chemist. What are you going into computer for? It's never too late to do an about face. Oh, you're in parade marching. You know what an about face is. You know what it is, you just don't know what it's called. Okay. It's like if you're in front of a platoon, that's happened before. Okay. At attention, you step back and do that. Looking the other way. That's an about face. Yep. Do you want to do an about face? Okay. So point is, so I've heard 3.1, I've heard 6.2, whatever number you just measured for the second time today, that goes up top, that is your percent yield. There's no right answer for this, okay? A lot of things can change, okay? Whether, you know, this might have changed a little bit or, okay, you were scraping it out of your beaker. Some of that is going to stick to your tongue depressor, okay? So when that does that, if you wanted that number even higher, you'd have to, for instance, take another tongue depressor and scrape that off of there just to raise that number even just a little bit more. Okay, so sounds to me like everyone got, would you say good data or reliable data or making sense data? That the math should always work out, and in this case it did. So it's a good learning experience for you. It's unfortunate that time doesn't allow for some of you to be in here. You just have to, how many people have a lab partner that's gone today? So, and you would have to help me out here. Is there, if I walked over there, are there any precipitates still sitting there? Because both lab partners are gone. Would you be aware of that or no?
For sure.
That group over there? Okay. Okay. So the one thing that okay. So hopefully we have a pretty good understanding of this content now. We got time for questions. Is there anything that you want just a little clarification, or just do a random problem on limiting reactants and percent yields? Otherwise, I'm going to go ahead and shut this off and pass back your papers. So rut row. Is it rut row is good or rut row oh no?
Rut row, all good.
Okay. Need that clarification. Second row. Third row. Okay. All right. So just like I've got after a different class today, if you're doing this, you're saying that you understand this. Okay? So be ready to go tomorrow, and I don't need those papers. Okay? So it was just more so for your benefit to go through it and follow along with the data. Yes, ma'am. Okay, we'll catch up with you next time.